A block of mass 5 kg is placed at rest on a table on rough surface. Is rest on the rough surface. Coefficient of friction is here. Now, a force of 30 Newton is applied in the direction parallel to the surface of table. The block slides through a distance. The distance is what it say 50 meter. Okay, an interval of time is 20 seconds. Coefficient of kinetic friction. What is the coefficient of kinetic friction? Yes. So this just you take about this is a horizontal surface. On the horizontal surface, so this is a rough place. On the rough place here, a block is placed. Block, its mass is 5 kg. Okay, so this is what initially at rest, and so this some force is applied parallel to this one. It's a 30 Newton is so applied in the direction of parallel to the surface, and it displaces from here to here. This came from here to here. The displacement is 50 meter. This is 50 meter. Okay, and in the interval of time, time is given t is equals to 10 seconds. So what is the coefficient of kinetic friction? So this is based on completely is what from the topic is what friction for the calculation of about coefficient of kinetic friction. Normal reaction, this is normal reaction n, its weight is what mg, mg means 50. Frictional force, it is tending to move downward rightward direction. Frictional force is F. F is equals to mu into n, mu into mg. So what is the mu? Mu is we need to find, it's a m, mg is what mu into 50. Yes. So first I need to find about this acceleration. So to find the acceleration, s is equals to ut plus half a t square. Okay. Distance traveled is what 50 is equals to started from rest 0 into t plus half a into t square is 10 square. So this 50 is equals to half a into 10 into 10. Okay. So this is what 10 ones are 10, 5s are. 5 into 2 is equals to a into 10. So 10, 10 cancels. A is equals to 1 meter per second square. This is acceleration. So after getting this acceleration, we need to go for this free body diagram of 5 kg mass. This is what it's a 5 kg mass. Its applied force is 30 Newton and frictional force is in backward direction F. Acceleration is in forward direction. Okay, we need to write the equation for this. When you draw the free body diagram, F net is equals to 30 minus F. F net means MA. 5A is equals to 30 minus F means what? Mu into what? N. So 5 into it's a 1 is equals to 30 minus mu into N is what? Mg. So Mg means 5 into G is what you say? It's a 10. Okay. So this will become as what? 50 mu. 50 mu is equals to 30 minus 5. 50 mu is equals to what? It's a 25. Mu is equals to 25 by 50. 25 ones are 25. 2s are. So the answer is what? 0.5. So the option C is correct. Here is the question. The question is given. Uh, this is as shown in the figure. As shown in the figure, a block of mass 10 kg lying on a horizontal surface. So pulled by a force is F, acting at an angle of 30 degrees. So 30 degrees with the horizontal. The mu value is given. It's a 0.25. So the block will just start to move. Just to start to move means what to remember here. So Fs, okay, coefficient of maximum static friction. This is limiting one. is equals to what? Applied force. This is the condition for it. Okay. So then the find the value of F is the asking question. Okay. So the question from here now I'm choosing is this. Here whichever is given, this is the force is resolved into the two components. Okay. This become as what? F cos 30 degrees. This is F sin 30 degrees. It's a normal reaction. Again, it's what? N. N is normal reaction. Its weight is what? Mg. Okay. This is what? Mg. Now its mass is given. So the mass is mentioned. It's a 10 kg. So it's what? 10 g. It's a 100. 10 into 10. Now we can write for the first situation on this. So what are the upward forces are mentioned? F sine 30, F sine 30 is equal to, okay, so this is what? F sine 30 plus N is equals to, Mg means what? 100. Okay. F by 2 plus N is equals to 100. N is equals to 100 minus F by 2. N is equals to 200 minus F by 2 is my first situation for the normal reaction. The block, so just tends to move, okay? So tends to move means what? Yeah. So frictional force, this is a frictional force. Frictional force limiting friction, so is balanced by what? So the applied force is what? F cos 30. Okay, so in the direction of motion, F cos 30. So FL means what? Mu S into N is equals to F cos 30 is value is root 3 by 2. So mu S is given 0.25 into N value 200 minus F by 2 is equals to, so F into root 3 by 2. You can go for proper calculation. So we will get about the value of what? It's a F. Okay. So now I'm taking as this 2 and 2 cancels. Yes. So 0.25 into 200 means 25 twos are 50. So this is 50 minus, okay, 0.25 F is equals to root 3 F. Okay. So this is 50 is equals to 25. 0.25 means what? Plus 0.25 into F. Okay. Plus root 3 means 1.732 F. So 50 is equals to, it's a 1.982 F. So it's a 50 by 1.982, 1.982, this is what? F. 1.982 means what? Nearly 2. So 50 by 2 is what? It's 25. So it's about 25. What is this? This is the answer. Now your answer is what? 25.2 Newton is your answer. So this is the question. The question is what? A mass M is attached to two springs as shown in the figure. Okay, the spring constants of two springs are K1 and K2. Okay, this. Now we can apply this. Just for understanding, we can move on that. Now, here, this is what? It's a mean position, right? If I displace this block towards to x distance, means what? It will be compressed by x. This is elongated by x. Okay. So I can say you that for the first one is what? What is the concept based on this? The concept is combination of springs. Okay. So this is about combination of springs. So combination of springs, what? It's a series and parallel combination. So next condition I can say from this, when the block is displaced, when the block is displaced, so right side, This is right side through a distance x. Right side through a distance x. So that first block, one spring, one spring, one spring elongates x distance, and another spring. So another spring compressed. Okay, so this is compressed by what? X distance. It's what? X distance. So from this, what do you understand here? This, the direction of the both the springs, the direction of force, which force is the spring force on both the springs, both the springs is same direction. So springs is same direction. So for the same direction means what? They are connected in what? In a parallel combination. So this is what? It's a parallel combination. In the parallel combination, so what is the effective springs constant? Effective springs constant is what? K equivalent. K equivalent is equals to K1 plus K2. What is the time period? T is equals to 2 pi under root of m by K equivalent. T is equals to 2 pi under root of m by K equivalent is what? K1 plus K2 is the relation. So T is equals to 2 pi square root of m by K1 plus K2. So the answer is first. A small block of mass 100 gram, its mass is given 100 gram this, and to a spring of springs constant is 7.5 Newton per meter. The other end of the spring is fixed at a particular point A if the block moves in a circular path. So this is the fixed point, here is the spring. So this is what? Block of mass m. Yes. So it moves then with a circular path like around this. Yes. So during this, springs constant is K, and central force is balanced by what? Spring force, Fs. Central force is balanced by what? Spring force. So now when it is elongated, let the elongation of the spring, elongation of the spring, the elongation of the spring is equals to x. Okay. So then Fs is equals to Fc, Kx is equals to mr omega square. So what is the r from this? So r is after the elongation, r is equals to some, its initial length is L plus x I'm taking on this. Okay. So this is what now? K x is equals to m into, so r means what you say? It's a L plus x omega square. Okay. So then the values of k as given, it's a 7.5, x is equals to mass is, so 100 gram means 0.1 kg, and its length, the length as, so length is 20 centimeter. 20 centimeter means what? 0.2 meter. This is 0.2 plus x into omega square. So 7.5, 0.1, it's a 75, x is equals to 0.2 plus x into the value of omega is, it's a 5, so 5 square. This is what? It's a omega, so 5 square. So now 75 x is equals to 0.2 plus x into 5 square is what? 25. 25 ones are 25 threes are. 3x is equals to 0.2 plus x. It's a 3x minus x is equals to 0.2. 2x is equals to 0.2. X is equals to 0.1. Okay. So now he's asking about x, the value of x we got it as 0.1. Then the required tension is what? What is the required tension? Required tension. Required tension. So tension is what? T. T is equals to what? It's a kx. T is equals to the value of k is what? It's a 5. 5 into 0.1. Answer is what? 0.5 Newton. So option C is correct. At any instant, the velocity of the particle and mass is given. Mass m is what? It's a 500 gram means what? 0.5 kg, and its velocity is given as v is equals to 2t I cap plus 3t square j cap meter per second. So if the force acting on a particle, so this is F is equals to I cap plus x j cap Newton. So then what is the value of x at t is equals to 1 second is asking. So then this is the general equation for the differentiation, and force we need to take about this F, we have the F, okay. So from here, first I need to find acceleration. Yes. So then first one from here, this A is equals to dv by dt. So this is equals to d by dt times of 2t I cap plus 3t square j cap. So this is 2I cap plus 6t j cap. So is the acceleration. So now we can take on this force F is equals to what? M into A. Vectorially, F bar is equals to M into A bar. So F bar is what? Just I want to know about F bar. This is equals to, what is the mass is given? 0.5. A bar is given 2I cap plus 6t j cap. Okay, T value is what? 1. F bar is equals to 0.5 into 2. It's a 1 into I cap plus, so this is 1. 0.5, 6 5s are 33 j cap. Okay, so our given question is what? F is equals to I cap plus x j cap. So what is the value of x now? This x is equals to what? It's a 3. So the answer is option A is correct. Given below, two statements are mentioned. An electric fan continues to rotate with some time after the current is switched off. Okay. So when fan is rotating, first condition, what is the concept on this? When fan is rotating, when fan is rotating, so it needs it needs some what? Kinetic energy. Yes, it needs some kinetic energy. And next one, so when the switched is second point, I can say this, when switched off. Okay, so when switched off, this is switched off. When it is switched off, when it is switched off, what happens now? So due to air resistance, after some time it comes to rest. Okay, so then its energy gradually decreases, it comes to rest. So due to air resistance, due to air resistance, air resistance, so the fan comes to rest. So fan comes to rest. So that we can say, so due to inertia, okay, due to inertia of motion. So inertia of motion. So due to inertia, so we can say as inertia of motion, the fan continues. So due to inertia of motion, the fan continues, okay, in a rest. Okay, otherwise after when it is switched off, it comes to rest. Okay, so in the given position, then what is your answer? So Option A is correct and B is the correct explanation of A. A coin is placed on a rotating table. This is rotating table. So it is rotating with respect to some vertical axis. Its angular velocity is omega. When a coin is placed here, this is the coin of its mass is m. And from here to here distance is what? So place it at a distance of 1 centimeter. This is what 1 centimeter. And from the center, if the angular velocity of the table is halved, so first one is omega, next one is what he mentioned as first one is omega, next case is what you say, it's a omega by 2. Okay, it will just slip to where? So it here, so just slip means what? Just tends to slip, just tends to slip. Tends to slip means what? Here at this position, its a central force should be balanced by what? Frictional force. Okay. So central force Fs is equals to what? Fc. Fs means what? Mu into n is equals to mr omega square. Okay. So what is the mu? Mu is here not mentioned anything. It's a mu. And next one, n is what you say, it's a mg is equals to, so m, r means what, it's a 1 omega square, cancels. So then I can say you that this is mu g is equals to, omega square is my first equation. And second case, in the case 2 I am taking as this. For the case 2 is what? Angular velocity is half. It became as half. Then what do you say? Mu g is equals to, so mu g is equals to, what is the condition? R omega square. Mu g is equals to R dash. Omega means what? Omega by 2 whole square. So from these two cases, if you solve on this equations from the 2 by 1, mu g by mu g is equals to r dash omega by 2 whole square by omega square. These two cancel. 1 is equals to omega square by 4 omega square into r dash. This cancel. R dash is equals to 1 into 4, then r dash is equals to, what is the answer? 4 centimeter. What is the new distance? So it just tends to move when angular velocity is halved. So the answer is what? It's a B. A body of mass 500 gram. The mass of the body is given m. So moves along with x-axis. Its velocity varies. Its velocity varies with a displacement. So that's what is given here. This is v is equals to 10 root x meter per second. What is the force acting on the body? Okay. So force acting on the body means what? F is equals to m into A. A can be calculated in what? One is dv by dt with respect to time. One is v into dv by dx. So with respect to what? It's a position. With respect to position means what? We need to choose this. F is equals to m v dv by dx. F is equals to m is m only. What is the velocity? 10 root x into d by dx times of, what is this? 10 root x. So this will become as m into 10 root x. So into, so 10 differentiation of root x is what? 1 by 2 root x. Okay, root x and root x cancels. 2 1s are, 2 5s are. So then f is equals to m into 10 into, it's a 5. So m is given. So this is what mass 500 gram. 500 gram means what? 0.5 kg into 10 into 5. So this is 5 5s are 25 Newton. Option B is correct. Position vector of a particle related with a time. So this is mentioned r bar is equals to 10t I cap plus 15t square j cap plus 7 k cap meter. The direction of net force experienced by the particle is what? Net force means what? F is equals to m into a. So F bar is equals to m into a bar, that we need to find on this. So for that, what to do? I'm talking about this its velocity, next acceleration, then substitution in this case. So what is the velocity? V bar. V bar is equals to dr bar by dt. So this is what d by dt times of. So r bar is what you said 10t I cap plus 15t square j cap plus it's a 7 k cap. So this is what 10 plus 10 I cap plus 15 twos are 30 j cap plus it's a 0. So this is 10 I cap plus 30 j cap. Okay, 30 15 t square means what? 30 t j cap. This is velocity. Now if you write acceleration, acceleration A is equals to dv by dt. So dv by dt means what? This part is 0 plus 30, it's a j cap. Differentiation of t is what? 1. A bar is equals to 30 j cap is the direction. So he's asking about the force. F bar is equals to m into a bar. So this is m mass only. A bar is what? 30. It's a j cap. What is the direction of force? Along with the positive y-axis. A uniform chain of 6-meter length. Okay, so 6-meter length. This is hanging over the table. So this is what it's a 6-meter length. Now this chain is hanging like. Now total length is what you say, it's a capital letter L, and place on such that a part of its length is hanging, okay, over the edge from the table. The system is at rest. The coefficient of static friction between the chain and surface of the table is what? It's a mu value is given 0.5. The maximum length of the chain hanging from the table is what? Let it be this length is what? X, which is hanging from here. Okay. So just you take about from here, this from lambda is what? Linear mass density. Okay, linear mass density. Okay, so lambda is equals to mass per length. So m is equals to what? Lambda into L. Okay, so total length is what? L. So this is x. This will become as what? L minus x. Okay, now careful on this. Now I am talking on this. What is the mass of this part? Mass m is equals to lambda into L minus x. What is the mass of this part? So this is what? Lambda into what? It's a x. So what is the normal reaction? Normal reaction is n. Its weight is what? Mg. So frictional force is acting like this. It's a Fs, right? So then n is equals to what? Mg. N is equals to m means what? What is the mass? Lambda into L minus x. Okay, G is the normal reaction. Now, so why it is balanced here? So because the frictional force is balanced by weight of this hanging part. Okay, frictional force is equals to frictional force is equals to the weight of hanging part. Okay, hanging chain. So weight of hanging chain. Frictional force is what? Fs. Fs is equals to what is the weight of this one? M. For example, this is M1 I am taking, this is what? M2 I am taking. M2G. Fs means what? Mu s into N is equals to M2 into G. Okay. So it's what? Mu s. So what is the N we have? Lambda times of L minus x into G is equals to M2 means what you say? Lambda into x into G. G and G cancels. Okay, lambda also cancels. So then mu s into L is given, we have the value of L is what? 6 minus x is equals to, so it's what we have x. Okay, and mu s value also there 0.5. 0.5, this is what it says, 0.5. 0.5 means 1 by 2. 1 by 2 into 6 minus x is equals to x. Okay, 6 minus x is equals to 2x. 6 is equals to 3x. X is equals to what it say? 2. So it's mentioned in meter, or means meter only. Centimeter means you can take centimeter. It has given in a meters. Okay. So the answer is what it say? 2 meter.